opioid crisis is continuing unabated. It's not going to stop anytime soon. The FDA, the CDC, everybody's weighing in. Everybody has an opinion about what to do. But we can't undercut the physician's ability to prescribe drugs to people who are in pain.
I am a postdoc in Dr. Khanna's lab. I have been for the past 11 months, and I am also a Regulonix employee. Personally, it was a member of my family who had cancer, and one of the things that was mostly affecting her quality of life was pain. When I asked her how she was, what she would say is it hurt. And the doctors had had a very hard time adjusting her medication so that her pain would be taken care of, but she would still have a good quality of life without too much side effects. One of them being that you are basically sleeping all the time, and so you're not really living.
So the reason we started Regulonix was to combat the opioid epidemic in a way by designing new drugs that would bypass the need for opioids and would not be addictive. The chemotactic thing?
Yeah. We have results for the blood, for the characterization of the immune cells in the blood and in the spleen.
We're measuring neurons, so we think it's from neurons, but it could also be affected by the other cells. So by doing it with the CAMK2, which is only neurons, and then also deleting it only in the astrocytes, maybe we can begin to see something. The AZ is done, right? You're doing the... So our approach has been a little bit different. What we're doing is to regulate, hence the name, Regulonix, regulators of ion channels. So it's not all ion channels, it's one flavor of an ion channel called the sodium NAV 1.7 channel. So it has 8 other cousins, but we're only targeting this one channel. And the way we're doing it is different from others in that we're not trying to block access of ions through this channel. There are other kinds of sodium channels, there are other kinds of calcium channels, potassium channels, which we're not touching. And that's important because some of these other channels are important for things like your heartbeat. Imagine unimaginable chronic pain as really high volume sound. And so our approach is essentially dial down that volume of sound to a lull using a regulatory protein, and that's how we control pain. We have one lead compound that we thought is fantastic. We know it's fantastic. It's called AZ194. It works to mitigate pain in an acute model and 3 or 4 models of chronic neuropathic pain, but we don't know whether chemically it's optimized enough. What I mean by that is it optimized enough to have a sufficient half-life? Is it going to be in the body for just 30 minutes or 4 hours or 8 hours? With the guidance of Marcel Patek, who's our MedChem consultant, we're able to look at the structure. He was able to look at the structure and figure out where we could change things to tweak the molecule. Now, we did that. So we ordered 47 of those compounds, tweaking them in different places to see what part of that core structure of the chemical was important. These purple-blue cells are filled with a dye which is going to change in color depending on whether pathway is inhibited or not. And if they don't inhibit those cardiac channels or muscle channels, then we take the compound forward to this platform and test them in these sensory neurons. Raymond right now is patching and recording cells from rat sensory neurons. For our lead compound, 194, we do see inhibition in mouse, in rat, in pig, and in human, which gives us great confidence that this compound should be able to regulate across the species.
So I do basic fundamental research on all of the mechanisms that will cause pain and mostly cause pain to change from the normal physiological pain that you are supposed to experience because this is what protects you of everything that can be harmful in your environment, and the transition to this chronic pain that should not be there, that doesn't have a purpose. So we can study that, and on the other side, with Regulonix and with Dr. Khanna, I get the chance to study molecules that have a potential to become drug in a really short time. We are talking like not decades, we are talking a few years.
I think it would be phenomenal to be able to help get a drug to market that controls pain, chronic pain, without all these horrible side effects, that's pretty huge. That's groundbreaking. It's something that's needed. So I think that would be that's beyond my wildest dreams. You know, I'm a scientist, a molecular neurobiologist, a guy who plays with little molecules and proteins, and to be able to use that information to develop something could be used globally. That's very humbling.